All right, last one from the 8-1 warm-up was number 4, which is finding the sum. So that little e, which is read as sigma, this is your summation notation, okay? And then the number at the bottom is called the lower bound. Number at the top is called the upper bound. So I use those to plug them in, right, one at a time and add them all together, which means I'm going to start with which one? K equals 2, okay? So I'm going to take k equals 2. I'm going to plug 2 in the place of k, and I get 2/3. And then I move on to k equals 3. 3 plus 3 plus 1, 3 over 3 plus 1, sorry, which is 3/4. And then I go to k equals 4. 4 plus 1, which is 4/5. How do I know when to stop? Top number, and not 5 terms, right? I'm not saying I want to do 5 total terms. I'm saying that this is lower bound, this is upper bound. So k equals 5 is where I'm going to stop. So 5 over 5 plus 1, which is 5/6. Now I've got to take, that would be if it's a series, but now I got to take and add these all together. So what's the least common denominator of 3, 4, 5, and 6? It's a number they all go into. So start with your multiples of 6. They obviously don't all go to 6, right? Do they all go into 12? No. 18? No. 24? No. 30? Okay. Nope. 36? No. 42? What comes next? 48? Do they all go into 48? No. What would be next? 54? Do they all go into 54? What comes next? 60? Do they all go into 60? Yay, so we found the winner. Okay, so we got to change these so they all have 60 as a denominator. So I'd have to multiply this by 20, which means this is 40 over 60. Multiply this times 15, which means that's 45 over 60. This times 12, which means that's 48 over 60. And this times 10, which means it's 50 over 60. So 40 plus 45 plus 48 plus 50 for my numerators. Okay, this is 85 plus 48. 133 plus 50, that's 183. Over 60, and then I got to see if it can be simplified. So they're both not even. They can't both be divided by 2. But the trick for 3s is if you add up the digits, right? So if I do 1 plus 8 plus 3, I get 12. Is 12 divisible by 3? Yes. So this would be divided by 3, and I'd get 61 over, divide this by 3, and I'd get 20. 61 is not, it's actually prime. It's not divisible by 2 or 3. So I would leave it as 61 over 20. Questions on that one? So summation starts at the bottom number, stops at the top number. You're taking them and plugging them in one at a time and then adding them together. Any questions on the homework that was due yesterday, the 8-1 part 1? Or the classwork that you worked on yesterday, 8-1 part 2? Everybody's good? Yeah? Okay. 2 is called arithmetic sequences and partial sums. So for 8-2 and 8-3, we're going to continue with sequences, but we're going to learn about a special relationship between the numbers. Today's is called an arithmetic sequence. And then also in both sections, we're going to learn a different kind of sum, like where that summation comes into play, and today's partial sums. So an arithmetic sequence is a sequence that has the same difference between the numbers, between the consecutive numbers. So as I'm moving from left to right throughout my sequence, the numbers are changing in the same amount. You're either adding the same number or subtracting the same number from one to get to the other. So if a sub 1, a sub 2, a sub 3, and a sub n, where it would end, is arithmetic, then if you take 2 and subtract 1, it's going to be the same as if you took the third term and subtract the second. Same thing as if you took the fourth term and subtract the third. That difference is called the common difference. So some vocab here. The difference is called the common difference, and the variable that you use to represent it is d. D can be positive or negative. So if the numbers are increasing, D is going to be positive because you're adding that number every time. And D can be negative. If they're decreasing, then you're subtracting that number every time. Then D can also be negative, okay? But it's arithmetic if it changes in the same way every time. If you're adding, sorry, not just changes. adding or subtracting the same number every time. So example 1 says determine whether or not the sequence is arithmetic, and if it is, find the common difference. So we want to look at the numbers that are there. It goes from 3.7 to 4.3, 4.3 to 4.9, 4.9 to 5.5, and 6.1 to 5, or 5.5 to 6.1. So I want to take the second one, or 4.3, and I want to subtract the first one from it. So 4.3 minus 4.7 is what? Oh, that's a 3.7, sorry. .6. And then if I did 4.9 minus 4.3, it'd be 0.6. And then if I did 5.5 minus 4.3, it's 0. If I did that right, that would be helpful. 4.9, 0.6. And then 6.1 minus 5.5. 0.6. So because these are the same every time, this is an arithmetic sequence. So the answer is yes, it's arithmetic. And the value of D is a positive 0.6. It is increasing every time by 0.6. Example 2 says, write the first 5 terms of the sequence. Determine whether it or not the sequence is arithmetic. And if it is, find the common difference. So now we're going back to what we learned in 8.1 at the beginning. We're taking an a sub n, and we want to find the first 5 terms of the sequence. So a sub 1 would be 150 minus 7 times 1. A sub 2 would be 150 minus 7 times 2. A sub 3, 150 minus 7 times 3. A sub 4, 150 minus 7 times 4. And a sub 5, 150 minus 7 times 5. So 150, minus 7, which is 143. 150 minus 14, which is 136. 150 minus 21, 129. 150 minus 28, 122. And 150 minus 35, 115. So those are the first 5 terms of the sequence. That's the first part. 143, 136, 129, 122, and 115. Second part says determine whether or not the sequence is arithmetic. So are these changing in the same interval? The difference from 143 to 136 is what? -7. How about 136 to 129? Same, right? 129 to 122, -7, 122 to 115, -7. So this is also arithmetic. This time, because it's decreasing, right? D is -7. All right, now we're finding the nth term. So we're going back to where we have to come up with the equation. This time it's easier. It's much easier because you don't have to try to figure out the pattern. You have an equation to plug it into. So the nth term of an arithmetic sequence, and we're going to learn a couple of these, so it's important to make sure you're paying attention to the wording. The nth term of the arithmetic sequence is in the form of a sub n equals n sub 1, so the first term, plus n minus 1 times d. Or you can switch that order around, doesn't matter. A sub n would equal a sub 1 plus d times n minus 1. So in order to know the nth term or the equation for the nth term, you need the first term and you need the common difference. You'll keep n as n. You'll distribute that d to both and then simplify it. All right, so it says find a formula for, and this should be a sub n, God bless you, for the arithmetic sequence. So 1, it's already telling you it's arithmetic, okay? 2, you're looking for the equation. So if I've got, let me write it up here again, a sub n equals a sub 1 plus d times n minus 1. So a gives you everything you need. You've got the a sub 1 and the d right there. So I would say a sub n equals a sub 1, which is 100, plus a negative 8 times n minus 1. And then you want to simplify it. So distribute the negative 8 and combine your like terms. And there's your equation for a sub n for an arithmetic sequence. All right, so B, little different. This time you've got 4, 3 halves, negative 1, negative 7 halves. So I know what a sub 1 is. That's 4. What I don't know yet is what the common difference is. So what would be 3 halves minus 4, or 3 halves minus 8 halves? That's negative 5 halves. Now, I only have to figure it out once because it's telling you it's arithmetic this time. But if you wanted to confirm it, you could do negative 1 minus 3 halves. You'd get the same thing. So this is now D. So now when I plug it in, I'd get a sub n equals a sub 1, which is 4, minus 5 halves n minus 1. Distribute the negative 5 halves. And then combine like terms. So again, this is 8 halves. 8 halves plus 5 halves would be 13 over 2 minus 5 over 2n. So sometimes it will give it to you straightforward where you've got a sub 1 and d. Sometimes you're going to have to do a little bit of work to get to it. Everybody still good? Yes? All right, write the first 5 terms of the arithmetic sequence. So I would say you kind of have 2 choices here. One is if it actually said first find a sub n, then you would want to do it the way we just did it. I would want to say a sub n equals negative 10 plus negative 12 times n minus 1. Or a sub n equals negative 10 minus 12n plus 12, which is a sub n equals 2 minus 12n. I could do it that way, and then I could take and plug in 1, 2, 3, 4, and 5, right, to find the first 5 terms. You with me? Yeah. Or if it doesn't ask for find a sub n, I can simply take these numbers and adjust them. If the first one is negative 10, how would I get to the second one? If d is negative 12, what would I do with 10? Negative 10. Subtract 12. So negative 10 minus 12 would be negative 22. Negative 22 minus 12, negative 34. Negative 34 minus 12, negative 46. And negative 46 minus 12, negative 58. So again, if it had said first find this and then find the 5 terms, then I'd definitely go this route. I'd figure out what a sub n is and plug in 1, 2, 3, 4, and 5. If it just said write the first 5 terms, then you can simply take that first term and add d to it until you get to the 5 terms.
Wouldn't that make d 12 though?
Wouldn't. What?
22 plus 12 would make 10. Like the difference.
Say that again?
Like to find the d, wouldn't you like negative 22 like
minus a negative 10.
So with the negative, wouldn't it become
Positive. So it would be negative 22 plus 10, which is negative 12. Right? So you're saying if you wanted to check it, minus a negative 10, that would be plus 10, right? Negative 12. Does that make sense?
Yeah.
Okay. Gotcha. All right, this one says, write the first 5 terms of the arithmetic sequence. And actually, this should be recursive. Sorry, recursive. Write the first 5 terms of the recursive sequence, find the common difference, and then write the nth term of the sequence as a function of n. So remember that little notation, k plus 1 and k, that's recursive. That means you're using the number before it to get to the one that's next. So if a sub 1 is 8, then how do I get to a sub 2? Add the 3, right? So 8 plus 3, which is 11. A sub 3, I take the one before it, which is 11, and add 3, 14. A sub 4, 14 plus 3, 17. And then the last one, a sub 5, 17 plus 3, 20. So the first 5 terms would be 8, because you have to include that one, then 11, then 14, then 17, then 20. Then it says, write the common difference. So what's D for 8 to 11, 11 to 14, 14 to 17, 17 to 20? Positive 3, right? So D is 3. And then it says, write the nth term. This is your equation. A sub n equals a sub 1 plus d times n minus 1. A sub 1 was 8 plus d, which is 3, n minus 1, 8 plus 3n minus 3, or 5 plus 3n. All right, now it says the first 2 terms of the arithmetic sequence are given. Find the missing term. So important is the word arithmetic. It's telling you it's arithmetic, which means that it's going to continue to be the same jump. So if I go from a sub 1 being 8 and a sub 2 being 11, what is D? 3. And then it says find the missing term. I want to go to a sub 8. So you actually have 2 choices, right? What's one way you could do this? I can keep adding 8 till I get to 3, till I get to a sub 8, right? So I'd go to a sub 3, add 3 again, 4, add 3 again, 5, add 3 again, 6, add 3 again, 7, add 3 again, 8. Okay, what's the other way you could do it?
You plug in an 8 for the n.
Good. So you can figure out a sub n, which would be 8 plus 3n minus 1. This is what we just did. Or 5 plus 3n. And then I'd go directly to a sub 8. So I'd say a sub 8 equals 5 plus 3 times 8. 5 plus 24, which is 29. So depending on how many jumps there are from where you're at and where you want to go, it might make more sense to just keep adding D. If you're jumping a bunch, it would make more sense to find a sub n first. Or if it says find a sub n, and then find the rest, then obviously you would come up with your equation first and then plug it in. All right, second topic in this section is the sum of a finite arithmetic sequence. So if I wanted to find the sum of a set of numbers that A, have to be in an arithmetic sequence, B, terminate, so there's a finite amount of those numbers, then I find it by saying the sum of those numbers equals n, which is the number of terms, times a sub 1, which would be the first one, plus a sub n, which would be the last one. So it's number of terms over 2 times first plus last. And again, this only works for an arithmetic sequence. We're going to eventually get into infinite sums. Okay, that's different. This is a finite sum. So this is great SAT prep stuff because they love these kinds of questions, because honestly, you could do this without this equation, but it would take you a whole heck of a lot longer. Okay, maybe not the first one, but the second one for sure. So if it said find the sum of the finite arithmetic sequence, and I look at the first one, it wants you to find 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20. Obviously, calculator you could do, I mean, you could even add these, right? And it's going to take you a little bit of time, but the second one you'd see it would take you a lot more time. But let's say we want to find it using the equation. So I want to say that n over 2 times first plus last. So the first thing I need to know from this is how many terms there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 terms there. What's the first term? 2. What's the last term? 20. So this would be 5 times 22, which is 110. And again, this time, probably not a huge deal to sit there and add them all up. But then you get something like B. Find the sum of the first 100 positive integers, where you would have to do 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, all the way up to 100, okay? Which can be done, but is certainly going to take a lot of time. So it's way better to do it this way. So if it's the set of the first 100 positive integers, how many terms are in that set? 100. What's the first positive integer? Nope. 1, right? You're thinking even, right? What's the last positive integer? 100. So I'd get 50 times 101, which is 5,050. All right, now variations of what kind of information you're going to get given. Let's say you're given 2 terms and a number of terms. So let's say you're given A1 and A2 and then the number of terms. For those, you can find D using A sub 1 and A sub 2. And then you can find the equation of A sub n using our nth term if it's arithmetic, or A sub 1 plus n minus 1 times D. And then find the last term using that equation, or A sub n, and then find the sum of what we just did. So this would be if you're given 2 terms, like let's say A sub 1 and A sub 2, and then the number of terms, but what you don't have is the last term. So you'd have to figure out D to find out what the formula is, and then figure out the A sub n, which would be the last one, and then plug it into the sum that we just had. The second variation is if you're given a summation. So let's say you're given something like we had at the beginning of today. Well, I don't even remember what was over here. Whatever was over there, okay? You would use the bottom number to find A sub n. A sub 1, sorry. You would use the top number to find A sub n, and then you can use this equation to find the sum. Looks something like this. The first one says find the indicated nth partial sum of the arithmetic sequence, or the direction say. And yours, I think, is a typo, right? Because yours is not arithmetic. Does it say 1.1 on the second one or something like that? Right? Change it so it matches what's on the screen. Otherwise, it's not arithmetic. So it should be 0.5, 1.3, 2.1, 2.9, and n is 10. So for my sum equation, I need the number of terms over 2 first plus last. What of that information do you already have? Say again. I know the n is 10. Do you have the first term? Yep, 0.5. Do you have the last term? No, that's what I'm missing. So the first thing I got to do is find that. What I do know is this is arithmetic. What's 1.3 minus 0.5? 0.8. What's 1.2 or 2.1 minus 1.3? 0.8, right? So if it's arithmetic, then it should be the same. So I know D is positive 0.8 because it's increasing every time. So then A sub n would be 0.5 plus 0.8 times n minus 1. With me so far? Now, if I wanted the actual equation, I could continue to work this out. 0.8n minus 0.8. And I'd get negative 0.3 plus 0.8n. That's an A. But really what I need to find is A sub n, where n is 10. So A sub 10 would be negative 0.3 plus 0.8 times 10, or negative 0.3 plus 8, which is 7.7. And for that, you could have also plugged it in here. You didn't have to wait until it was simplified. I would say only simplify it if it asks for A sub n. But that would be A sub n, which is our last term. So I plug it back in. And then I'd get 5 times 8.2, which is 41.0 or 41. Okay, then look at B. Again, same equation. I want the partial sum, so n over 2 first plus last. Do I know what n is this time? What is it? 25. What's the first? 100. And the last? 220. So I already have everything I need this time. 12.5 times 320. Which is 4,000. Questions on either of those? So you're just going to get the content delivered to you in different ways. They're going to give you different information. You just got to be able to decipher what you have and what you need and how to get there. Okay, last one gives it to you in terms of a sum. So this says find the partial sum without using a graphing utility. So let's say it had just said find the sum at the start of today, and I gave you that. What would you have to do? One, you would hate me, right? Because you'd have to start at 1, and then go to 2, and then go to 3, and then go to 4, and go to, right? So this can be done that way. It would not be fun, but it can be done that way, okay? But now that we know the partial sum equation, then I know n over 2 times first plus last. If the number on the bottom is 1, if the lower bound is 1, then the n is the top number. So if I start at 1 and go to 500, there are 500 terms, right? If I go from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 terms, yes? So that would be 500 over 2. How would I know the first one? I'd take the number on the bottom and plug it in. So 1 plus 8 would be 9. How do I know the last one? Where would I stop? What would be n? The top number, right? So I take the 500 and plug it in, and I'd get 508. So then I'd get 250 times 517. So I'd get 131,250. This is, again, another example where you could figure this out without the formula. You could plug in 1, then 2, then 3, then 4, then 5, then 6, all the way up to 500. It would take you a lot of time. Okay, but you could do it that way. Okay, the other thing you have to watch is what happens if the number on the bottom is not 1. So let's say that it said n equals 2 and the number was 500. How is that going to affect my equation?
It's not 500
It's not 500 numbers anymore. How many less numbers is it? One less number. Does that make sense? So if that said 2, then it's actually 499 numbers. If it said 3, it's 498 numbers, right? So for every number you get past 1, you have to subtract those numbers from the end. Does that make sense? If it was instead 0, how does that impact it? Now you're adding an extra 1. So it very rarely it's not going to say like n equals -5. If it did, then you would be adding on 6 terms, okay? But if it said 0 there, you know it's not just 500 terms anymore. It's 501. So again, if it starts at 1, then n equals the top number. If it starts at 0, it's the top plus 1. If it starts at anything bigger than 1, it's at the top minus the difference between that number and 1. I don't even know how to write that. N minus 1. So if it was 2, then you're taking away 1. If it's 3, you're taking away 2. If it's 4, you're taking away 3. So on and so forth. That minus 1. And then also when you go to find your a sub 1, obviously your a sub 1 is now whatever the number on the bottom is. So if that number on the bottom was 2, then my first term is if I plug in 2. If my number is 0, then my first term is if I plug in 0. Does that make sense? Okay. It says without using a graphing utility, you're not going to have a graphing utility on your quiz or your test for this kind of question. Feel free to use it to check your answers for homework, but don't use it to find the answers. Questions on arithmetic sequences or partial sums. Yep.
Did you do that if it wasn't M plus E, it was just a whole number?
Say that one more time.
Like to the right of the E?
Yeah.
If it was just a whole number instead of the M plus E, you used to be able to do it?
Yeah. So, because you'd just be adding 8. Yep. Wait, no. For this process, though, for the n over 2,
yeah.
No, because that's not a arithmetic sequence.
Okay.
So good question. So if it had said something like this, right, and it said 500 again, we won't do it all the way out, equals 1, and this number was 3, you're saying? That you would have to add 3 500 times, okay? Only if what is here is arithmetic. So if it was n plus 3, something like that, then you could do it. It has to be arithmetic. And then it's n over 2 times first plus last.